Welcome. My name is Phil Conrad, and this is a video about integration testing and end-to-end testing for Computer Science 156. This video goes along with Team03, at least in fall 24. If you're watching this in another quarter, the numbering of the assignments may be different, but it is likely that there will be an assignment just like this one. And the assignment starts with an introduction to this idea of the testing pyramid. And the idea is that the testing pyramid is that your testing suite for your application has three parts, and the unit tests form the base of your testing suite. And there should be more unit tests, ideally unit tests of as much of the code as possible. Unit tests test a single method or function in isolation, and they try to really focus on just that one unit. That's why it's called a unit test. If that unit depends on other things external to the unit, like other methods or functions, or interacting with a network service or interacting with a database call, we try to mock those network services, mock those database calls, so that we're not testing the unit test shouldn't fail because there's a problem with the database or because there's a problem with the network. Instead, we want to mock all the different situations that could happen with the database. The database call might return one record, a list of records, or no records at all. And we need to test whether our unit responds properly to each of those situations. So those are the unit tests, and those are the tests that we've been working with in all of the previous projects. But there are two other important kinds of tests. Integration tests will look a lot like some of the unit tests you've done, for example, for your controller methods. But in this time, where the controller method might depend on an external service that you might mock, it might depend on interacting with a network endpoint, which you might mock. It might depend on doing database calls that you might mock. With the integration test, you're still maybe focusing on one unit or method or controller, but this time the database is real. The network calls are real. You are testing the interaction, the integration of one unit with all the other units. So it's a more authentic test in some way. In some ways, they're a little harder to set up. They run a little slower, so we have fewer of those. But it is possible to have all your unit tests passing, and the application still actually doesn't work because even though all the pieces work in isolation, the interface between them is not correct. So the integration tests will check for that. Finally, end-to-end tests are in some ways the highest quality tests in terms of being able to test what is really important. An end-to-end test works with the application as what we call a black box or an opaque box. The idea is we cannot see inside the code. We know nothing about the code. We just know the web interface to the application, and we interact with the application the way a real user would. So we start by logging in, we start by clicking on buttons, on menus, filling in forms, clicking, and then making assertions about what shows up on the web page. Now you might think, well, this looks a lot like the unit tests that we did for our front-end code. And you'd be right, with one exception. The unit tests we did on the front-end code, there isn't a real backend. There isn't a real database. Everything external to one of our front-end React pages is mocked through the mocking facilities of Jest and React Test Library and so forth. We use the Axios mock to mock the backend, for example. We mock the React library that puts toast messages up on the screen. We mock the parts of React that allow us to navigate from one page to another. In end-to-end tests, we use a framework such as Playwright. That's the one we're going to use. There are other frameworks like Cypress that actually allow you to control a real browser and that browser can be it can be Firefox, or it can be Chrome, or it can be one of the many other browsers. The browsers have a way of remote controlling the browser to cause it to do things. So we are working with an actual deployment of the real application, the full application. That's why we call it an end-to-end test, because it is the entire process from logging in to navigating the screens, filling in the screens, and then seeing what actually comes back. Testing the application the way a human would, but doing it with a robotically controlled script that we write in Java or JavaScript or Python or whatever the language may be. In our case, we're going to do it with Java. And the reason we could have done it with JavaScript, but there is still a little bit of mocking we need to do. In particular, we need to mock the OAuth authentication. The reason for that is that the only other choice is to embed real UCSB Google usernames and passwords in our tests, and we don't want to do that. That would be a extreme security risk if either you or I were to take our actual UCSB credentials, the ones that we use for everything, from checking our email to registering for classes to paying your bill to assigning grades, depending on your role. That credential is something that we do not want to put at risk, because if it gets leaked, well, gosh, someone could take over your whole life. So that is not an option. And we can't really ask. I mean, we could ask, but the university would say no, to ask for some sort of fake credentials that we could use for testing. That's something you could do at an organization. We don't have that option. So we will be mocking the OAuth part of the application. And there may be some other things that we have to mock, but we want to mock as little as possible. The idea of the end-to-end test is, as much as possible, we want this to be a real implementation of the app that is exactly the same as it would be in production, and we interact with it exactly as a real user would. Now, there are a few complications. For example, every time you set up a test, you need the database to be in a known state. So this is the reason that the end-to-end tests sit at the top of the pyramid, and there are much fewer of them. They are really a lot of effort has to go into first of all, setting up a framework where you can even do end-to-end tests. For example, being able to mock the OAuth endpoint. Each time you set one of these up, you have to set up a brand new instance of the database so that your assertions about what comes up on the screen will be valid. And you have to reset the database after each one of your tests, again, so that everything will be in a known state so that you can make assertions about what comes up on the screen. So in short, these are a lot easier to write. They run much faster. These run a bit slower and are a bit harder to write. These are the hardest to write of all and the slowest. So this proportion, lots of unit tests, a few integration tests, and a very few end-to-end tests, seems to be the sweet spot that many organizations have decided is the best practice for setting up testing for an application. All right, so with that in mind, that is basically the introduction. We are ready to actually get started on the coding. So I'm going to actually stop this video so that we have a separation between this introduction to integration and end-to-end testing and actually getting started on the coding. So thank you for watching this introduction. In the next video, we will actually start on the steps here in part 1.1. So thanks for watching.